Okay, welcome to Quantitative Methods, BBA 240. I'm your lecturer. My name is Amakao Mole. Okay, so as you can see from the course outline, we'll start with an introduction to statistics, then we'll go to presentation of data, then measures of central tendency, measures of dispersion and position, then we'll go to probability, and there we'll go to discrete random variables, binomial and Poisson distribution, the normal distribution, then we'll go into sampling distribution of the mean, estimation, hypothesis testing, analysis of variance, and finally end with simple linear regression. Okay. Okay, and then end with simple linear regression. So this will be a very interesting journey. Okay, it will be a very interesting journey. All you need to do for this course is to really study hard. Okay, so you need to study. You need to invest some time in it. Okay, and just do all the exercises and the practice quizzes that I'll be uploading on Moodle. Okay, very important too that you need in this course is the scientific calculator. Okay, so that is very, very important. Okay, so we're going to have a lecture, and this will be in form of a recorded lecture, just like this one. Okay, and we'll also be having a tutorial once a week. Okay, so I expect you to go through the lectures, the recorded lectures. Okay, and at the end of each week, we'll be having a quiz to practice. Okay, so I will be always online on Moodle. So for any questions, please feel free to ask. Okay, and you can also contact me on my email. Okay, so no conference, just email and Moodle. I'll get whatever question that you have. Okay, so you also have the prescribed implemented books on the course outline. So please get those books for the business math, basic business statistics. I will upload on the portal, so you'll be able to download it. Okay. So we start, of course, I need your participation. Yeah. It's a very nice course, and you will really enjoy it. Okay. Okay, so the expected outcomes just needs to expect you to be able to define statistics, describe the key data collection methods, know the types of data, and know key definitions such as population versus sample, the difference between a variable and a parameter and a statistic. Okay, so those are some of the things that I expect you to know at the end of this lecture. Okay. So it is very nice, and you will enjoy it. Okay. So we start with the definition of statistics. So statistics is just a branch of mathematics that examines ways to process and analyze data. So there is some mathematics component there. Okay, so there is some mathematics components using mathematics to analyze and process data. So this is all we are doing. Okay, so statistics is also divided into two branches, that is descriptive and comparative statistics. So descriptive actually just looks at ways of collecting, summarizing, and presenting data. Okay, so data is just unprocessed information. Okay, so that is just unprocessed information. But inferential statistics uses sample data to draw conclusions. So when you're drawing conclusions, when we're making those decisions, we are actually doing inferential statistics. Okay, so some terms that are frequently used in statistics, we have variable, population, sample, parameter, and statistic. Okay, so a variable is just a characteristic of an item or individual. Okay, so any characteristic will be a variable. Okay, so let's say the time that you report for work, number of books that you have, number of courses that you're taking, okay, number of students in your program of study. Okay, so those are characteristics of an individual or an item. Okay, so a population is just will consist of all items or individuals about which you want to reach a conclusion. So all individuals or items under consideration, that will be called our population. And our sample is a portion. Okay, so the sample is just a portion of a population. So if I pick 5 students from this class and ask them the time that they logged on Moodle. Okay, so that number, the 5 students that I have asked out of the whole number of students in PPA 240 will be my sample. Okay, now that is the difference between a sample and a population. A sample is just a part of a population. A parameter is a measure that describes a characteristic of a population. Okay, and a statistic is a measure that describes a characteristic of a sample. Okay, so any characteristic about a population will be a parameter. Okay, and any characteristic of a sample is our statistic. Okay, so an example will be the population will include all full-time students in PPA 240. So all the full-time students, that will be our population. Okay, or we can say all voters that are likely to take part in the next election, that will be our population. All lecturers at universities, that is also our population. Okay, so from this population, we can draw samples. Okay, so a sample could be hundreds full-time students selected for a research. So we're getting a part of all the full-time students, that is our sample. Okay, so even from all the voters that are likely to vote next year, if we just have a sample of 5,000 voters in this sample, okay, then that is our sample. Yeah. Then, from all the lecturers at UNILAS, which is our population, we can draw a sample that is 20 lecturers at Pioneer Campus. Okay, so that is our sample because it is part of the population. Now, the average number of courses of all full-time students in PPA 240. Okay, so this we're not considering all full-time students. Okay, so since we are considering all full-time students, then that parameter, that is the average number of courses, will become a parameter. Okay, yeah, so that is a parameter. Yeah. So, but the average number of courses for 100 full-time students. Okay, so now it is a characteristic of the sample because they're just taking 100 full-time students out of all the full-time students in the education. So that now becomes a statistic. So that is the difference between statistics and the sample. Okay, so now we move to sources of data. Okay, so we have primary sources of data and secondary sources of data. The primary sources of data include observations, surveys, and experimentations. Okay, whereas the secondary is the data that you use that has been collected by someone else, or you get any documentation from someone else to use for your research. That will be considered secondary data. But the primary data is the data that you collect as a researcher. So you can do it by observation, by a survey, conducting a survey, or an experiment. Okay. Okay, so we now move to the types of data. So we have qualitative data and quantitative data. Qualitative is also known as categorical data. Okay, and quantitative data is also known as numerical data. Now, qualitative data is just data that can be categorized. Okay, this includes marital status, political information, eye color. Okay, for gender, you can either just be male or female. Okay, you can't have anything else. Okay. Okay, yeah, it is pointing. So you can just have male or female. Then, political information, you can either belong to one party or another. You can only be categorized. Okay, either belong to this or that. Okay, the eye color as well, some have got blue eyes, brown eyes, and all that. So you can only categorize, you can't count. Okay. And for quantitative data, this is data that can be counted. Okay, that is numerical. Okay, so we have data that can be represented by a continuous scale, like weight and height. You have maybe 85.6 kg, okay, and you have height like 1.76, like that is my height, so that is continuous. But for discrete, it is only, it can just be used by countable numbers, like number of children. You can only have 2, 3. You can't have 1.5 children. Okay, so that is with the types of data. So those are the definitions. Okay. Okay, so with categorical data, it can be divided into 2 branches as well. Okay, we can have nominal variables and ordinal variables. Okay, so actually, we can also call them measurement scales. So we can have a nominal scale and an ordinal scale. So a nominal scale just classifies data that can be categorized without any ranking. Okay. If we talk about gender, male and female, there's no gender that is higher than the other. Okay. If you talk about political parties, there's no party that is higher than the other. So they are all, you can just categorize them. Look at eye color. You can just say brown, blue, right. Okay. So all those categories of eye color, They cannot be ranked. There's no color that is superior to the other. Talk about race. Talk about religion. There's no religion that is higher than the other. So there's no ranking. That is representing data on a nominal scale. But data that is represented on an ordinal scale can be categorized and further be ranked. Okay, so if you talk about economic status, we have the higher income people, then the middle, those with middle income, lower income, and all that. So that can be categorized, okay, and it can also be ranked. If you're asked to state your level of satisfaction towards something, okay, are you satisfied, not satisfied, not sure, dissatisfied, and all that. So that satisfaction can be ranked. Okay, you best categorize, but those categories can be ranked. So that is data that can be defined using an ordinal scale. Okay, so with the numerical values, you can use an interval scale or a ratio scale. Now, an interval scale is an ordered scale in which the difference between measurement is a meaningful quantity, but does not involve a true 0 point. Okay, so an example is the shoe sizes. Okay, so we have shoe sizes for children and shoe sizes for adults. Now, we have shoe sizes for children. As long as a shoe size is below 1 for adults, you have a size 13, 12, and then it goes down. Okay, but that doesn't mean that the difference between that shoe size for adults and the one for children is 12. Okay, so what it means there is that you have that difference, but it actually does not contain a true 0. So a shoe size for a 13, the difference between a 13 and size 1 for adults, it doesn't. Okay. Yeah, so what I'm trying to say is that the size below an adult size 1 is a child size 13. However, in each system, that is either using the children's size or the adult size, you have the interval that is equal. Okay, so if someone is a size 6 and the other one is a size 7, the difference is the same. And for children, one who wants size 12 and one who wants size 13, the difference is the same, but there is some gap between adult shoe sizes and children shoe sizes. Okay. Now, for a ratio scale, this is an ordered scale. The difference is the same and contains the true 0. The example is height. Whether it's children or adults, the difference is just the same. Because a child would be maybe 0 point something height. Okay, but an adult would be 1 point something. The difference is this. The difference just includes the 0. Whether it's an adult here in Zambia and a child in Zambia, the difference will just be the same as an adult in the UK and a child in the UK. So other examples include salary, age. Despite where you are, your age differences will just be the same. Okay. Okay, so this is the end of the first part. Now we look at our practice questions. So we told 4 different beverages are sold in a fast food restaurant. That is soft drinks, tea, coffee, and bottled water. Okay. Now, explain why the type of beverage sold is an example of a categorical data. Okay, so what we notice here is that we have categories. It's either that drink is a soft drink, or it's tea, it's coffee, or it's bottled water. Okay, so those are the categories that we have. That is why this variable, the type of beverage sold, is a categorical variable. Okay, now we have to explain why the type of variable is an example of a nominal scaled variable. Okay, so here, can we put any rank on the types of drinks sold? No, we can't. Okay, so we can't put any rank. Therefore, this is categorical, but it cannot, the drinks, the types of beverages cannot be ranked. Therefore, we have a nominal scale. Okay, now coffee is sold in 3 sizes: small, medium, large. Explain why the beverage size coffee is an example of an ordinal scaled variable. Okay, so the beverage size is an ordinal scaled variable because we have some rank. It's either small, medium, and large. We can rank those sizes. Now, suppose you measure the time it takes to download a video from the internet. Explain why the download time is a continuous numerical variable. Okay, so time, it can be put on a scale and a numerical scale. So it is a numerical variable. Now, is it continuous? Okay, so with time, we can have 2.5 seconds. Okay, we can have 1.5 minutes. We can have 2.25 minutes. So all that, it can be put into a continuous scale. It can have points. Okay, so that is why we're putting it as a continuous numerical variable. Why is it a ratio scale? Because the difference between any time contains a true zero. So it doesn't vary from place to place, and it doesn't vary regarding, no matter the place, okay, I think I've answered it. Yeah, doesn't vary from place to place. Now, the other question was that, so I'll leave the last question for you guys to do. Okay, so you have to categorize, or you have to classify these variables, whether it's categorical, numerical. If the variable is numerical, determine whether it's discrete or continuous. So discrete, remember, these are variables that can be counted using counting numbers like 1, 2, 3, 4, 5. Okay. And continuous are variables that can still be counted, but they contain points. Like they can only be put on a continuous scale, like 1.2, okay, 2.5, 6.8. Okay, so those variables that can be counted but can only be put in a continuous scale are continuous variables. Okay, so we end here. The next time we meet, a continuation actually of this video begins with frequency distribution. Okay, so thank you so much.